You guys are TrueZer0, and you launched today.
Yes.
And
Thank you, Karen.
Yeah, and you know, it's a beautiful vehicle. We got to see it yesterday. It's
right.
actually beautifully, elegantly simple. But
well, and it's also most than what most people can say. We actually launched today.
Right.
Yeah,
a lot of that.
Absolutely. Yeah, exactly. But it didn't quite go as planned. So
yes.
What happened there?
Well, what we saw was it came up. And I told it to go up to 10 meters, and we saw it lift up, and it corrected, and it came up to 10 meters and kind of paused there. But one thing you have to do, in this challenge, the pads are 100 meters apart. And at Holloman, where the challenge was meant to take place, they're at 50 meters apart. Mm-hmm. So you actually have to work harder here because you have to get up, and then you have to get over a much longer distance and then come down before you run out of fuel or before anything like that. So when I saw it come up to 10 meters, I said, great, looks okay. It was starting to spin a little bit, I think. But I commanded it to 55 meters, which is the height at which we fly to shoot across. As soon as I did that, and it gave it some thrust and it started to kind of lift up there, you could definitely see it starting to spin more. Mm-hmm. It started to get unstable as it was spinning, because if it spins too fast in this axis, it's pushing the gimbal around, it's pushing the motor around, trying to keep under it. But as the vehicle is spinning, it's trying to push. The gimbal's having to move in a circle, and it's working harder and harder and harder. Yeah. And so at some point it cannot keep up. So if it starts spinning too fast, the vehicle cannot stay under it, and it will fall out of the sky. Usually when that happens, at least in the simulator when I've seen that happen, it's going to go someplace that you don't want it to go. Mm-hmm. So as soon as I saw it starting to get a little bit too wobbly and knew that there was no way to correct that and no way to get it back on the ground safely, then I hit the abort. And as soon as I hit the abort, then Scott saw the vehicle start to come down, and he hit his abort. So that both aborts happened, and then of course the vehicle came down. His abort makes it vent. My abort just shuts it off and makes it come down.
It's guaranteed that once it's on the ground that it will continue to vent. So what we didn't want to happen is have them sitting on the ground with any pressure on them.
You're using hydrogen peroxide as well, correct?
Yes.
What would happen if you didn't vent that?
Well, if you didn't vent, then you've got peroxide in the tank. After hindsight, he would have vented himself. He hit hard enough to break things loose.
Well, he's pressurized with the nitrogen, right?
Right. So he's pressurized. So if he were to crash and not break something off like that, it would be sitting with pressure in it, and so it'd just be unsafe to try and approach the vehicle. And we couldn't. There's a chance we wouldn't be able to depressurize him anymore from the impact if we lose communication with him. We can no longer, try and activate our safety system.
And when it hit the ground, we lost communication with it. Definitely.
Was it hard to hit the abort switch?
No, I've hit it in a lot of our testing and so forth. It's something that you have to kind of be ready to do. You put a lot of time and effort into the thing. It's up there, and when you hit it, it's coming down, and it's going to be unpleasant, and you're going to have this to deal with. But you can't hesitate.
Well, as soon as I saw it, as soon as it started veering, I'm like, it's over.
Right, exactly.
I think everyone recognized.
Right, exactly, and you have to. I mean, you can't just I'll just kind of let it fly and see what happens. No, it's you make the choice.
Spinning like that, he's not going to fix himself. It's.
Well, why don't we go back to the beginning if we could?
Actually, really quickly, we only have a minute, so I want to just say very quickly that what you guys have done is amazing. And for people who don't know the general story, if you could do that really quickly, that would be great.
Scott, you want to take that one?
How you managed to get here from what I understand was a meat slicer.
In 1 minute. Well, that's how Todd and I met through work. We both are engineers. We do basically consulting work. I do product development. A customer came to us, designed a meat slicer. And how that was new for us is, it wasn't very new for me. I was just designing a mechanical system to drive the meat slicer, to drive the table, and so it automatically cuts. Mm-hmm. And so for Todd, that involved coming up with the electronics to drive a large motor, and I'll let him talk about that.
Sure.
But
as soon as the plane goes by. So yeah, for that project, the motor in that thing is about 1/3 horsepower, and that was more motor than I'd ever made hardware or software to try to control before, and it was great fun. I mean, when the thing started working and started pulling the thing through the slicer, and you could grab onto it and feel it adjust and pull harder than you could pull, it was great. It's kind of dangerous and great fun. And so we decided then to go, after that project finished, we're like, that was fun. Let's try to find something that's, as challenging and as interesting. And we made an electric go-kart with an even bigger motor on it. And then that translated into to an electric car with an even bigger motor on it. At that point, when that project was finishing up, then we found this one and decided that this would be a great next challenge to try to do and see if we could get to the finish line.
So you decided to do this when?
We decided to do this project. We found it in late December and actually started working on it January of this year. So
it's amazing what you've accomplished. Honestly,
thank you.
Honestly, it's thrilling to watch.
It definitely today was pretty thrilling to watch.
I gotta tell you, good TV.
There you go.
So how much was the vehicle again, top to bottom?
Well, if you count time and you count all the investment and the insurance to get here and all that, it's a lot. It's a scary amount. But you know, we gave our time to this project, knowing that it was a labor of love, knowing that it was something that was fun to do, and believe me, it was fun to do. And coming here has been fantastic. You know, although the end isn't what we would hope for, still it's an awesome experience. And I think when all of this settles down and we have time to get over the depression that we just crashed our vehicle, we'll remember this as a really cool thing. So it was worth that cost. The actual raw cost in the vehicle that just crashed is a fraction of the knowledge and everything else that we learned. You know, I think we estimated about $10,000 of bits and pieces just bit the dust over there. So not a tremendous amount in that respect. But
especially in rockets, I mean, that's
exactly
saying crazy low in this particular
right.
field.
We have tons of radios and things that we bought for the challenge, and there's tons of all this other, you know, paraphernalia that goes along with that, because there's a huge amount of stuff that backs that up. And if we decide to do this again, that's cost we will never have to bear again. So really it will come down to, you know, that much cost again to build it. But then we'll decide how brave we are to see if we want to try this again next year and possibly be sitting back at this table. So we'll find out.
So,
well, no, luck as in having landed luck.
all right, really quick, there was one question on the webcast that didn't get answered in the press conference really quick, and that is, if you do come back next year, what will you change?
I think you know, we got to the point where the thing was hovering, and it was doing fine on the tether, but we just didn't have time to take it off the tether, you know, to do a free flight with it, and that's it's a very difficult thing to do as well, because it's a dangerous thing to do, right? If you let this thing loose, and so you've got to find the right venue for that, and we don't have access to huge wide open spaces. We have enough access that we can do tethered flights, but a free flight with that is actually quite difficult to do. Out here in the desert is a perfect opportunity to try to test that kind of stuff. So if we do come back, I think we're going to have to find a way where we can actually do some of that testing, you know, prior to arriving here, so we can see these kinds of problems ahead of time and get them taken care of. But again, whether we come back or not, it's going to be a decision that's going to have to wait, because I don't think any of us are prepared to make it right now.
I understand. Well,
mechanically, I don't think I'd do a whole lot different though. There's you know, we'd have to fiddle a little bit with the motor, but I don't think we'd change. I think we'd stick with peroxide. It's very close to working. It's very close, so I wouldn't change much. I think we just need a little more time.
all right. Well, you know, we were all rooting for you.
Thank you, Ben.
was
I appreciate
all rooting for you, and we all hope we'll see you next year. I realize you guys got to think about it.
Yeah, exactly. We'll think about it, and we'll decide what happens.
Back here at this table next year.
You just come and
accepting your check.
commentate with us.
All right.
Yeah, absolutely.
Well, I think the response of everyone out there will kind of dictate. I think we'll look, you know, if there's a lot of positive response and people are eager to see people out there pushing and trying to do it, that's great. If there's a lot of negative response, like, oh, you should never have taken that out, you know, that kind of thing, you know, it might. Well, I don't know. Maybe not you. It might get to me. Anyway, thank you very much.
Thank you.
Absolutely.
Yes, thank you.
Thank you.